Thank you. I appreciate it. I've been hearing so many good things about you, and I've seen your art in this.
I can attest to that.
Here's the man that knows it all.
Yeah,
I've learned that already. The short time.
Covers on the panel. I'll go get it.
well, at least he thinks he knows it.
That's a little burden, I know.
Yeah, you know what? Not sure.
Oh, these are beautiful.
So when are you going to find out the results?
I don't know. I don't know. They're gonna do like a publisher's clearinghouse thing. I assume like they just want to surprise the winners and get
They're
press.
just going to show up in your classroom one day.
Apparently they'll coordinate it with they'll coordinate it with the principal and they'll do something.
Good.
If we win. So
Well, that would be good.
That would be great.
we'll see. Yeah, I'm very excited about it. I'm exhausted now.
Oh, I'm sure.
Good stuff. Good stuff. Now I'm seeing what I need to do now, which is talk to this company, do this, talk to this company, do that, and work on curriculum. Still got lots of projects on here, but good stuff to be doing.
That would be a good answer. I wish you could go right in.
I appreciate all your help. Happy to do it. You know
The
what?
original thing happened last December.
We should probably talk
I
about.
started to heal, and then
So
I
I'm looking to
think
do
I re-injured it.
December. That's probably too early. But December, I want to do like a thank you
Uneven sidewalk.
star party for everybody.
So
Similar to what we do now, which is just telescope workshop, go into the planetarium for a show, come on out,
this is on and off.
look at the telescopes. It'd be cool to have you there.
You know, I wanted to
Or
buy another one.
toward the summer when all of it is done, we can
Go out of
unveil
that
the planetarium.
for,
I could,
Yeah, that would have been.
Halloween.
Just for it.
You know, it's funny because I don't. Dave's first doing it. 10th of December.
I wish that was the right answer.
I have 2 or 3 stands.
So what did it?
Table full of things.
Well, it was an injury last December, just a misstep down some stairs.
So if you want to do something like that,
Started getting better, and then
you know,
I
especially if
think,
you want to get kids.
as far as I can rack my memory,
So,
a
I've been in
re-injury,
Manhattan Township and strong.
just coming off a sidewalk, a little
There's a lot of ways that.
uneven, a long time ago.
You
You know, like a couple weeks. Why is it hurting? I mean, just for good measure, I'm wearing it.
oh yeah.
And,
And then when I saw you, I sent you that note, it's like, you know, kids are
but
good.
I guess we heal, it's just a long road.
The older you get, the longer it takes
Um,
to heal.
If we can get their imaginations going.
I'm so careful anymore. And all my old injuries are coming back to home.
Oh, really? Oh, no, that's interesting.
More than
Oh,
You know,
fantastic.
the only thing I use, hey, Brooke, thanks for the
What was
donation.
this?
Oh yeah.
And then I just. Yeah, so I've done it with December 10th, I've done it with 3 already.
Yeah.
Okay.
You know, show them around, I just circle a real lot, show them stuff. That's 90% of my business.
Oh really?
Well, no, no, don't
Friendly reminders of what you did.
Yeah.
But the kids love it too. Well, good luck.
Oh, hey, thank you so much. I appreciate it.
It comes back to all, somebody. Hey, Rob, congrats.
Oh, no congratulations yet? We'll see.
I know.
I appreciate it.
We're at third base is going because I was at it again.
Yeah, I know.
Yeah.
Let me slide this to you. Listen to that on your own time. That's kind of my live thing, kind of just, you know, enjoy it. Yeah. And I'll be there
I live
again.
right near there, yeah.
December 2nd,
December 2nd.
I'll be there again.
Is that a Monday?
It should be a Friday, because
Should be a
that's when they
Friday.
do the thing from the,
Okay, Friday, December 2nd. I'm gonna make
I've
sure
been
we go out
pulling for
there.
you, man.
Oh, I appreciate it.
I know what it means to you.
How was it?
Yeah, West Virginia. Career topper. This year,
Really? Really? He's not the one who did the items here. Yeah. Well, wow, that would have been awesome.
So, yeah.
Another one.
It's like,
Almost yeah, there's almost heaven.
Yeah, it's almost heaven supposed to be great.
Yeah, that's a nice one too. That's about observations.
Yeah.
I was.
Is this the one where you can't use a cell phone because
I forgot to buy a pay card for the one thing from American.
you can't use it?
I don't care. I feel like we never go here.
I didn't know that way. I went
Princeton,
talking. They're talking. We couldn't afford everything. Oh,
yeah, so I'm so glad it turned out that way. I'm so glad
it was quite an event.
Okay. I just thought, no, Buzz is great, but he's not outstanding in science. I mean, he's outstanding what he did, on the mission, but I thought
He's getting the word out there.
for some reason, he was on the circuit, and they all wanted him, and I just stuck in Dyson at the last minute, and I was just.
All right, good evening. Good evening. All right, great to see everybody out tonight. So we have a lot to talk about tonight, so I'm going to be very brief in getting us started. First off, welcome back for those of you who've been here before. Is there anyone here for the first time tonight? Just trying to, I think I recognize everyone. All right, well, welcome back. Just so you're all aware, the Star Watch this month will be on the 25th or 26th, depending on what the weather, and this is our last Star Party of the season. You may have seen, if you are a subscriber to my email that I do every month, there has been discussion about doing potential members-only Star Watches. I know this is something that we've discussed in the past. We've done a number of trainings for people who are trying to learn their gear. That's something we want to do again. And we want to know, is there interest? So either is it a person who is trying to get training or someone who would like to help training. So I thought maybe I'd ask tonight, is there anybody who is interested in one or the other, either helping to train other people or maybe need, like to come out and just share your experience? Doesn't have to be training per se, but if you just want to do some members only stuff. Anyone who's interested? Okay, so good. I would like to try to make these at the more darker sky locations. I don't say they're perfect, but they are better than where we usually go. So those two locations that I can think of off the top of my head are Middle Creek and Muddy Run. So does that sound like something we'd be interested in, given that there may be more that you can see than normal, or is there any other options that you may be interested in?
And we're talking about one or the other of those in regards to those?
No, this is the last public one, and after that we're talking, we're talking December, January, February. Do we restart in March? I guess we restart in March with public stuff. And we can do more members only stuff beyond that. But our point is that we don't want to just do only public stuff. So keep that in mind if you are a member and you are interested. If you're not a member, the membership's $20 a year for individuals, $30 a year for families. It's pretty reasonable. We'll help you out if you're needing help with your gear, or maybe you don't have gear yet and you'd like to look into it through our telescope. That doesn't matter. Members, of course, you may be at different levels. We'll work with anybody. Okay, we want to try to build that into our routine as well. So yes, beyond just these, we're talking about members only stuff. That's maybe it would just be a different time of month. We would shoot towards the new moon, right? Because we're looking to try to look at deep sky objects. Unless the members, as we come together, say, hey, we'd like to look at the moon this month, and that's perfectly fine as well. We can talk about that as an observing group. Okay, but I think from what our discussions have been with Lane and Tom, we would try to shoot for the new moon so that we can see more. Right. What's the point of going to a dark sky location if you're dealing with moonshine? Right?
And is there any plan tonight to talk about the progress of Muddy Run, by the way?
Let's leave that till afterwards.
All right.
Okay. if you're interested, we can certainly talk about that after our presentation today. Okay, so we do have an observing with Webb. Rob is here, fresh off the press. I think I can still feel the heat coming off of this computer. He just got this done tonight, so thanks again, Rob. And here we go. Do we have a sound check on this, Lee? I don't think we did. So
It's on.
I know it's on, but let's just double check.
Hi everybody, and
That's
welcome
good.
to Observing with Webb for November of 2016, where the armchair astronomer figures out what they're looking at, why it's so cool, and what they should check out next. Don't forget to check out my Podbean page, my YouTube channel, which you're probably on right now, and my Twitter feed, all with the username MrWebbPV, MRWEBBPV. So November brings us good views of Venus, Mars, Jupiter, maybe some Leonid meteors, and hopefully some good news for the Pequot Valley Planetarium. Now, speaking of which, let me get this out of the way. Thank you, all of you, so much for your support. It was quite overwhelming. There were a lot of people voting that I didn't know. There were a lot of people who shared things with other people that I just couldn't keep up with it on Facebook. It was just amazing. It was fantastic. So please, let me thank you even if we don't win, thank you for bringing the community together. This was just so cool. I've heard many, many cool stories about their people's planetarium trips and all sorts of cool things. So just thank you. The Pequot Valley and the astronomy community are just great communities to be a part of. So thank you very much. Now, you might be thinking, well, what do you mean if we don't win? Here's the thing. So there's 15 proposals. The top 6 win. And I don't know where we are. They gave us rankings at 2 weeks out of the 4 and 3 weeks. And both times we were in 3rd place. And the top 3 places didn't change at all, but there was some mixing in the bottom. So I think that's really, really good news, but they won't tell me. They don't put out the rankings. In fact, they won't put out any rankings anymore. But what they will do is they will surprise me. They will surprise me with some sort of publisher's clearinghouse type of all-school assembly or something. I don't know. But anyway, so I'm not going to know until probably you know. And even so, I'll probably send out an email or something at that point. But just so you know, I'm not holding on to any news. We'll see what happens. So, anyway, speaking of October, did you catch the night launch? I did. It was actually really cool. If you caught my Facebook Live about it, I apologize because it was terrible. But I did get this picture here. And what you're seeing here in this picture is, well, this is the night launch of Antares right here. And what you see is that it's very, very bright, and it's burning, 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 burning. You're looking like Wallops Island is in this direction, but really far away, because I have an extra camera. And it's going up, 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 and then it's still burning, and then right about here is where it detaches from the first stage. Let's see if I can zoom in on this. There we go. Whoops. There we go. I can zoom in there and you can see it sort of just stops there. And then eventually it picks up again. And there's the second stage. I don't know what that blip is. I'm pretty sure I bumped the camera, but yeah, you know, stuff happens. Anyway, if you look at this, my picture, this is 222. You can see all the cars going by and a truck. And these are just power lines. Okay? And this is an airplane going by. And all the other little trails are stars. Because I had the camera open for about 3 minutes, so it was able to actually catch all of that, which was pretty cool. So I was very happy with that picture. But anyway, you're not here for October. You're here for November. So let's talk about November. Let's talk about the planets first. Then we'll talk about the events, and then we'll talk about the constellations. Good thing there's not too much going on in November. But Let's start at November 2nd, and let's look at the planets. After sunset, you're going to be able to see Venus, Saturn, and Mars. And here I kind of have them set up here, and I'll set this up so that it'll show us what's happening throughout the whole month. Let me set it to sunset. Now, in particular, tonight, November 2nd, you'll be able to see the Moon, Saturn, and Venus really close together, all three, which will be really neat. But you'll also be able to see Mars way over here. Now, this is at sunset. Let me go a little bit further. Let me go like 7 p.m., because that's about when it gets a little bit darker. So you notice you've got Venus, Saturn, and the Moon, and Mars, all a little bit lower in the sky than they were before. This is the Milky Way galaxy. You probably won't be able to see that. But it's... Anyway, for the planets, watch what happens throughout the month. You'll start seeing Saturn sort of move to the right and away from Venus. And Saturn's going to get closer to the Sun from our perspective. And Venus and Mars are sort of going to stay maybe a little bit closer, maybe a little bit further apart. But essentially, by mid-November, it's just Venus and Mars that you can see. And what you also notice is Mars is going through the constellation of Capricornus. And Venus is in Sagittarius, but Venus is very, very bright. So let me go back to the first. So what you're looking for with Venus, you're looking toward the southwest, you're looking for the brightest object in that direction. That's going to be Venus. Saturn's going to be dimmer and to the right. And, if you are looking for Mars, what you'll want to do is maybe wait till it gets a little bit darker. And if you're looking for Mars, you want to look for Capricornus, which is kind of tough. It's a dimmer constellation, but it's there. Or just look for Sagittarius, the teapot over here, and just move to the left a little bit, and you'll be able to find Mars. So again, Venus, you're looking about 10 or 20 degrees above the horizon. That's 10, 20, somewhere around there. Very bright. It's going to set around 8 p.m. For Mars, you want to look south-southwest after sunset, and it's going to be red. Remember, Mars is going to be good big red compared to everything else. And it's going to go through the triangle throughout the month. Just like that. Okay? And, so Saturn's going to be there too, but again, let me go back to the first. So I feel a little disjointed today. If I go back to the first, Saturn, you'll still be able to see it as the sun sets, or after the sun sets at like 7:30. But after a couple of days, it just gets way too low on the horizon. So Saturn's on its way out. Okay? All right. I forgot Jupiter. Now, unfortunately, there's no real planets to see throughout the night, although Mars does set around 10:30, so you can see Mars at least. But after that, there's no real visible with the naked eye planets. But after 10:30, Orion comes up. Gemini, and you see all these winter constellations. Now notice I'm looking east and going through the night. And what you'll notice is, there's Jupiter. Jupiter is our nice, excellent morning planet for the month. All you gotta do is look at the eastern sky in the morning after 5:30 at the beginning of the month, and then it's actually gonna rise earlier and earlier. So by the end of the month, if you're out at 4 a.m., you might catch it on the horizon. All you got to do is look for the very bright object in that direction. I've been watching it for the past 2 weeks now, and it's getting a little higher and higher in the sky every single morning. And it also helps that sunset is happening a little later and later, or earlier. Sunrise is happening later and later as well. But Jupiter's really good to catch out there. So, again, in the mornings, you'll see Jupiter out there in the east. And then in the evenings around sunset, you'll see maybe Saturn, definitely Venus, and definitely Mars. Okay? So let's talk about the events that are happening. In fact, I already talked about this first one, but November 2nd, you'll see a nice close encounter between Saturn, Venus, and the Moon. Again, the Moon is, I believe, 7 degrees away from Venus. And only about 2 degrees above Saturn, which is pretty good little collection. Now, let me zoom out a little bit. And if you know the motion of the moon, you notice that every day it's going to get a little higher in the sky and a little thicker. And by the 5th, it's going to be near Mars. Okay? In fact, on the 5th, what you're going to do is you're going to look, oh, you know what? I have to take off daylight savings time. I got to change my times. So after that, it's going to be daylight savings time. Excuse me. And on November 5th, at about 6 p.m., November 5th, yeesh, it's been a long month. I apologize. October was crazy. But anyway, on November 5th, the moon and Mars will be somewhat close together, about 7 degrees apart in the night sky. And then on the next night, the moon will be thicker and higher in the sky, and it will also again be about 7 degrees apart. And so the moon and Mars, you'll be able to see them in the same direction. This is a good time to look for Mars, because Mars is not that bright, but it is red, so it is somewhat easy to distinguish. But if you know the moon is around it, then you know you're looking in the right portion of the sky. All right, the first quarter moon is actually on the 7th, okay? And really, not much happens for the next week. If you do go outside and look at the moon, you'll see it gets thicker and thicker. It turns into a gibbous phase throughout the rest of this week. And then on November 14th, November 14th is the full moon. That means it's visible all night. The whole moon is visible from sunset to sunrise. And if we have some snow, it makes for really good visibility at night. Now, what's going to happen after that? Well, let's see. What we're going to have to do if we want to see the moon, we're going to have to get up later and later. Okay. And on the 17th, when the moon is right near Gemini, we are going to have the Leonid meteor shower. Now, let me explain a little bit about that. See, the Leonid meteor shower gets its name from the radiant of the meteors, where the meteors appear to come from Leo. So we have to go early in the morning to see Leo the lion. It's 2 a.m. And around that time is when it's going to be best to see. And so you'll see meteors streaking from Leo the lion. You know, one here, one there. But here's the thing, it's not going to be that great this year because that moon is big and bright. Well, it's bright. It's usually pretty much the same size. But it's a waning gibbous moon, very bright. It's going to put a lot of light pollution into the sky, which is going to dim out or overpower some of the dimmer constellations, or dimmer meteors. So, is it worth going out for a couple minutes, maybe 10 minutes? Absolutely. Is it worth packing all your stuff, going to Cherry Springs? No, not so much. But you might be able to see some really cool ones, especially the really bright ones. Again, if you know what happens with the moon, you notice that now in waning gibbous, it's going to get closer to a half moon, last quarter moon, which will happen on the 21st, and that's when the left half is lit up. And you can see this last quarter moon from about midnight is when it rises, all the way into the morning. You can actually see it in the morning sky. And then, oh, do you see something happening here? See Jupiter down there? See the moon up there? If you've seen the moon changing its position, you'll notice that it gets closer and closer and closer to Jupiter. And the closest it's going to be for this month is November 25th. And you're going to be able to see Jupiter and the moon not too far apart. In fact, I believe Jupiter is just 4 degrees up and to the right of the moon. It makes a good binocular sight. You might not be able to get both of them in there, but still, if you don't know where Jupiter is, the morning of the 25th is a good time to look. You just have to look southeast after 4:30 in the morning and before sunrise, which is about 8 a.m. So you have a good window. Just look for that thin crescent moon rising up, and Jupiter is about 4 degrees up and to the right. And again, if you notice the motion of the moon, you'll notice it gets closer and closer to the horizon and thinner until November 29th is when you have the new moon, and thus the darkest skies of the month. And that's what's going on for the month. It's not too much going on, but some very good views of Venus, Mars, and Jupiter. Mostly Jupiter and Venus, those are the best ones. But let me talk real quick about the constellations. You see, we're going 15 minutes. So let me wrap this up with just a few constellations. Let's go November 15th. And let's go sunset. Ooh, man, that's going to be 4:47. That's about 5 o'clock. Let's go a little bit deeper. Let's go like 7 o'clock at night, or 8 o'clock at night Eastern Standard Time. Mars is still out there. You will still be able to catch, in the west, these summer constellations. You can still find Lyra the Harp, Cygnus the Swan, and Aquila the Eagle, with Delphinus the Dolphin right there as well. But they're not going to be there for that long, because they're making room, they're leaving and making room for the fall constellations like Pegasus, you're looking for this great big square, and Andromeda, you're looking for these two curved lines. And they actually share a star, not technically, but they share a star. And what happens is throughout the night and throughout the season, those fall constellations will move across the sky and start to set, and then you'll be able to see, earlier and earlier each night, the winter constellations coming up, like Orion and Gemini, Auriga, and Canis Major, all really good ones. So I think I'm going to stop it there, and wish you very clear dark skies for the month of November, and I hope you get out, maybe see some Leonids, or just catching Venus and Jupiter, I think is going to be my goal for the month. So clear dark skies.
All right, so we just want to point out one thing that I found was interesting. I've been watching Orion every morning. I get to work and I watch Orion. That's kind of my routine each year because it is my favorite constellation. And I've been watching it slowly moving towards the western horizon each morning. And it's something that if you're up early in the morning, kind of observe, because as soon as it starts to be setting in the morning, when the sun is coming up, is not too long after that you're going to start seeing it rising right after sunset, right? 180 degrees away from each other. So it's an interesting thing, not only to watch it seasonally, but if you're able to watch it morning versus night, that same transition happens. So for the early riser as well. All right, we have upcoming next, we have Tom with some deep sky objects. Tom?
Okay, for November, these will be the binocular and small telescope objects. And the constellations I'll be focusing on is Andromeda, Aries, Perseus, Pisces, and Triangula. And here's a star map. Now this is one that Orion Telescopes puts out. It's kind of a nice one. The other ones are skymaps.com. A lot of you get pick that one up. And of course that one has narrative on what's going to be out there in the sky. But this is shows the planets available too. And I'm always look at what's around 9 o'clock at night. So that's why I'm putting out, you know, Andromeda and Triangulum. They're the stars that are in the south and high enough that they're above the atmosphere to be able to see some objects, especially with binoculars or small telescope. That's on the Orion. It's on their website under Community, and then upper bar articles, and then you can see monthly sky chart. Okay, for Andromeda, obviously Andromeda Nebula, this can be seen with the naked eye, and even in moderate light pollution. And it's really the farthest object you can see with the naked eye. It's 2.5 million light years away. Now, of course, with a telescope, to be able to see M32 and NGC 205 satellite galaxy, you're going to need a telescope. Small one, to be able to see that. But also, there's a globular cluster here, G1, that you're going to need a larger telescope to see, probably about a 10-inch, and a dark sky. Okay, open clusters, NGC 752, 5.7 magnitude, with one for binoculars. That's about 1.3 degrees wide. Also, a nice double, Gamma Andromedae, blue and gold, very similar to Albireo. And that's a 2.3 and 5 magnitude, about a 9.7 separation. So you really need to have a telescope. Binoculars aren't going to do it. You need to be about 30 arc seconds to be able to split a double with binoculars. Depends, of course, what type. Probably a 15 by 70. That's a very nice double star to see with a small telescope. Okay, this is the location then. Here you can see the Andromeda Nebula. Rob had just pointed that out with his constellations. And right here at the third star, on the large square of Pegasus, you'll see this faint little fuzzy. And of course it shows Gamma Andromeda, or Gamma, the double star, and also the cluster NGC 752. Now this is also posted on, you go into the website under meetings, it's under the archive file. And just look up the date for this meeting and you'll be able to see this, so instead of having to take notes. Aries, small constellation, very faint, very difficult to see in light pollution, but they call it the ram's eyes, and these are a double, both at the same magnitude, 4.8, so they look like the eyes of the ram. And another 7.8 arc seconds separation. You need a telescope minimum about 100 power to see that. Perseus, of course, the famous double cluster is beautiful in binoculars. I mean, in fact, binoculars are better with it because, you know, the separation, each are about 35 arc minutes wide, and really to get both of them in the same, you have a small telescope that's a wide field eyepiece with about 2-degree field. But that's why binoculars really look great with looking at them. Binoculars is fantastic.
Can you just clarify with like the fingers, like that'd be like what, 1 finger across widthwise at arm's length?
Yeah, about
2 fingers maybe.
Yeah, right.
So if you hold your arm out like
if
this.
a fist is 10, yeah,
Yeah.
exactly. But that one is, and I'll show you where to see that one. It's another little fuzzy, and then when you put your binoculars on, it really looks. And the M34 is another cluster, about 5.2 magnitude, easily seen in binoculars also. About 35 arc minutes wide, about the span of the full moon. Algol, which is a eclipsing binary, and of course you see a little light curve here showing the smaller curve. Of course, when it goes in front of the blue giant, of course, it really distinguishes. Normally magnitude 2.1, but reduces in brightness to about 3.4 magnitude every 2 days. So this is something you can actually see and observe the difference in the magnitude over a period of a couple of days. Another double, Eta, 3.8, 8.5 magnitude, about 28.3 separation. You should be able to separate this in a pair of 20 by 80 binoculars. And that's a nice golden blue, again, good variation in color.
Hey, Tom?
Yes.
With Algol,
Yeah.
the dip happens about every 2 days. How long does the dip itself last? Is that like hours or?
I'm trying to think, I think it's hours.
Okay.
It starts to, you know.
It is ours, yes.
Yeah, right, it's hours.
This
So
is
yeah.
sorry, this is something that I don't know, is there interest in? Because this is something I find fairly interesting, and would this be a potential discussion topic with binary stars, and maybe specifically with eclipsing binaries? How many people would think that would be an interesting, like, monthly topic, maybe? So we're just running out of ideas and trying to get ideas, to be honest. Okay.
Yeah, this is a very famous one, and I'd like, since it happens in a matter of hours, you can see it actually decrease in a matter of almost 3 days. You can see the change, and it's a dramatic change, especially when you're looking at pair of binoculars. Yes? Yeah.
Why on the graph is the second dip in dotted lines on the right?
I don't know, you have to ask whoever made it. I didn't make that one. so.
It's all just happening fast. We'll go into detail.
Does magnitude work negatively?
Yes, it does.
So the bright,
I mean,
when it
there's
passes in front of it,
negative.
it's gonna be brighter, which means it'll be a more negative number.
Well, it's 2.1 magnitudes and it goes to 3.4, which means, you know, it's gonna get fainter.
In other words, the small star
Small-
is blocking some of the bright star's light, even though it's emitting light of its own. It's still blocking some
So
of
it's
it.
gonna drop to 3.
So that's why you get a double dip.
Right. Any questions on that? Okay, Perseus, another, as a small planetary called the Little Dumbbell. If you ever look at Messier 27 in Vulpecula, this is a smaller version. Looks like about maybe 1/4 the size of the M27. It's about 10.1 magnitudes, and an oxygen-free filter helps, but it is really a telescope object, small telescope. You can see.
Does that make, I'm new to this, the filters. When I did this a long time ago, the filters were professional. Is it that significant to make that investment?
Yes. If you're going to buy only one filter,
Yeah.
and I'll eventually give a talk on filters and even sun filters and everything else, I'd get an O3. I mean, because you can really bring out planetaries. It doesn't work on galaxies or anything like that, but it does work on anything that's an emission type of nebula.
There's some that are visible, and some that are not. So, if you're, depends on what you're doing, imaging or taking out or visual with your eyes.
But if you're going to have a telescope that's 6 inches, the objective or the mirror, or less, it's not going to help you that much.
No.
It's only because it does darken the background quite substantially. Okay, these are locations here. Looking at the W of Cassiopeia, and the top of the head of Perseus. Right in the middle, you'll see this little pink fuzzy. Well, that's the double cluster, and it looks fantastic in a pair of binoculars. Shows M76, the little dumbbell, and of course I'm showing Andromeda here. I already showed that, and M34 is the other cluster that's in Perseus. Pisces, galaxy M74, about 9.4 magnitude. Now this will be a telescope object. That's a very nice spiral that shows its face on to us. It's about 1.5 degrees northeast of Eta. That shows it right here. Very close to the star. It's right there, too, with a small telescope. Also, Uranus is located in this location this month also. So if you're going to look at the M74, you can look at Uranus, and you can see that with a pair of binoculars. With binoculars. Yes?
So my biggest challenge is trying to figure out what is visible here versus dark skies like trace.
Well,
are these all related to here, or
these are for moderate light polluted skies. Because if it's going to be a Cherry Springs thing, so nobody's going to be running up there to see them. So I'm looking at when you have just like moderate. If you look out here, if you didn't have these lights out in the parking lot, okay, you can see the Milky Way faintly lit. I see it from my house, which is up the hill. So I'm looking at that type of moderate light pollution. You'll be able to, I'm picking these. The other ones are too faint. If you get too much light pollution, I don't care what size telescope you're going to have, it's going to spread it out. It's going to be invisible. Okay, Triangulum, of course, the famous M33, the pinwheel galaxy, 5.7 magnitude. Now this has low surface brightness because it's face on and it's large, so its brightness is spread out over the object and makes it faint. But you can see it in modern light polluted skies, and especially with like a 15 by 70 binoculars. 15 is the power, 70 is the objective lens, or a small telescope. And this is what it's going to look like. It's going to be just a faint fuzzy like that. You need to get a larger telescope to be able to see some of the spiral arms. A larger telescope view at a dark sky where you actually see spirals. And this location, the triangle, and then M33 is here, and of course Andromeda is up this way, just south of Andromeda. Okay.
Okay, our speaker for the night is Steve Conard. Sorry. We had him here, was it April? Yeah, that sounds about right, to talk about the New Horizons spacecraft just before it got to Pluto. He's an optical engineer, okay, and designed and helped build the camera, one of the cameras that's on that spacecraft. So we're going to be hearing from that camera again in about 2 years, right? When it gets to its next Kuiper Belt object. So hopefully everything's running by then. But give us a, when you start your talk, give us a quick rundown on the state of the spacecraft and everything, okay? So, Steve, I'm going to read this so I don't make any mistakes. Steve's an optical systems engineer for Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland. He has developed hardware for space missions for over 30 years, hence the gray hair. And he's also an amateur, very much an amateur astronomer, and his enjoyment for telescope making as a teenager led him to a career in optics. So, Steve, the floor is yours.
Can I just unplug this one?
Yep. Yeah, if you want to move that out of the way, you're welcome.
Or you can just perfect. We're sitting on one of the cables.
Okay, so I'm going to talk about occultation timing tonight, mainly asteroidal occultations. This is my hobby science I do. So if you were with me almost a month ago in my backyard at 2 a.m., and I think it was a Tuesday night or something like that, and we were looking with a little telescope pointing at Sculptor, we would have seen something like this. I'll get this shot. Always failed at the wrong time.
The joy of technology.
Isn't that what happened to Hubble?
I see some things on there.
That's a
Yeah.
second dust.
There's a star lower left to you, Aaron.
Yeah. Yeah, I see that.
It's about midway, a little bit to the right.
Yeah.
There you go. You're within a degree of.
You should just click and run, unfortunately.
It's the video, right? Yeah.
It ran last night. Well, okay, I'm going to wing it then at this point, unfortunately. So what we would have seen is there's a bright star here that would have blinked out for, the video would have worked for about 30 seconds and then came back. And what happened, that was an asteroid occultation, and I'll explain what that means in a few minutes. It's going to really not be good if my other video doesn't work either. So anyway, what I'll talk about is what are occultations, why do I take the time and effort to go out at 2 in the morning when I got to work, got to get up for work at 5:30 the same morning to go to work, some of the results we get, and what you have to do to collect data if you're interested in collecting data from this. So Wikipedia says an occultation is any event where one object hides another object by passing between it and the observer. In astronomy, we further define them as lunar. So when the moon goes in front of a star or a planet, that's a lunar occultation. Planetary, they're somewhat more rare. When a planet or planetary satellite goes in front of another solar system body or a star. An asteroid is when an asteroid hides a star. So what we do, by the way, I'm a member of the International Occultation Timing Association, where timing is a prominent word. So why do we bother to time when, for example, the moon goes in front of a star? Prior to LRO, Lunar Reconnaissance Orbiter, and Kaibuga, or however you pronounce that, I butcher pronunciations all over the place. Prior to those space missions that orbited the moon, the timings were used to measure the height of mountains on the edge of the moon. Because we know precisely where the star is in space, we know where the center of the moon is, so you can, by knowing when the star blinked out or when it came back, you can measure the height of a mountain on the moon relative to the rest of the moon. So back in the Apollo days and all, that was a really important thing. There was a lot of amateurs doing occultation timing of lunar features. And this is, if anybody's heard of David Dunham, he's the gentleman that sort of invented this back when he was a teenager. And I worked with David on the New Horizons program at AELC. He invented this, and there were a large number of amateurs back in the 60s doing this, doing manual timings of features on the moon to help with the Apollo program at the time. So now, since we know the height of all the mountains on the moon, we don't need to do it for that reason. So the primary purpose now is actually to find double stars. Is the moon sweeps across fast enough that if you have a video camera looking at that star, video cameras generally run 30 frames a second, 30 pictures a second. You can resolve 1/100th of an arc second. So you guys were just talking about double stars that were 10 arc seconds apart, things like that. So it's 1/1000th of your 10 arc second double star. And what we found is if you were looking at stars that haven't been timed before, lunar occultations that haven't been timed before, if you time 100 of them, you're likely to find one double star that wasn't previously known. So it's an opportunity to have a discovery moment in your life if you want to.
Why does that happen? I mean, are they not optically separable?
Right. Now, they might be spectroscopically separable, but there are so many stars in the sky that haven't taken spectrum.
Right, okay, so it's too close for...
Yeah. Yeah, 1/100th of an arc second is, you need to go like Hubble, or I don't even think really good adaptive optics goes that far now. Might get close, but. And then there's the planetary occultations. So when Jupiter or something like that goes in front of a star or another body, it used to be that measuring the size of those bodies, how big Neptune is or something like that was the driver. Now, there's a little bit of work that maybe for atmospheres and for centaurs and KBOs, that we consider them with the planets, discovery of ring structures. But that gets me to asteroids, and this is what I do the majority of my astronomy time at home. So why do we do this? We measure the size and shape of asteroids by doing this. So if we time when a star blinks out behind an asteroid, when it comes back, and we know where we are on Earth, we know where the star was, we have our friends who are doing the same thing. So you can imagine, I'll show geometry in a second, but you can imagine there's a path that goes across the Earth where this shadow goes across. If you have enough people across that shadow who timed when it went away and when it came back, you know a chord along that path. So you can get a bunch of chords and you can measure the size and shape of an asteroid by doing that. So we can resolve things better than the Keck telescope can using telescopes as small as 35 millimeters. Okay, so some of the work we do, we split in half Walmart binoculars for the brighter events and make portable stations. That's just a video camera and a 35 millimeter half binocular. We also can get very accurate positions of the asteroids because we know where the stars are very well. And we know where the asteroid crossed it, so we can help with asteroid orbit determination. And again, we also find double stars this way, accidentally. When the star we thought was a single, the asteroid goes across it, and we get a two-step process. I'll show you an example of that. It's also a really neat party trick. If my wife doesn't like astronomy, she'll come out once a year to look at Saturn. But if she has the opportunity to see a star blink out, she just thinks that's very cool. Okay, so why are amateurs doing this? Okay, for the most part, it is purely an amateur sport. The major exception is for Kuiper belt objects, where you need a big telescope and oftentimes very costly imagers, like $30,000 cameras going on your big telescope, in order to detect the very faint stars they typically go over, because they tracks so little area of the sky. So you have to wait for them to go over some star that might be a really, really faint star. So for amateurs, we do it because the equipment's relatively expensive. I don't want to say it's cheap. You know, it's hundreds of dollars investment. If you already have a telescope, it's not thousands of dollars. We're very used to going mobile. I mean, we're talking to people at dinner tonight who go up to Cherry Springs and places like that. So we're used to throwing the stuff in the car and going somewhere. So if there's a shadow path going across, you know, up in Pottsville or something like that, you guys can get in the car and you can drive up there in an hour and set up there. We're also scattered all throughout the country. These things are happening everywhere all the time, even in the middle of daylight. Can't measure them in daylight for the most part, but so they're just always happening. So if you live in, you know, New York City, remember a couple of years ago, if you guys heard about this, when we thought Regulus was going to get occulted, and the path was going to go right through New York City and up towards the Great Lakes. You know, the idea there was we were going to have 10,000 people in the city of New York looking for this thing. Of course, it got clouded out everywhere on the path, but that's what happens in March.
So in the daytime, closing your eyes doesn't work?
It can. You can just hit the stopwatch too. And also, it's a very part-time activity. So the most dedicated observers, you know, often try less than 1 week. I sign up for about 50 a year. I'm clouded out at half the time down in Maryland, so I probably do 25 or so a year. So even though we're amateurs, our results are regularly published, and professional astronomers ask for our assistance. And one organization, Southwest Research, has started to experiment with reimbursing amateurs the cost of their travel to do this, to take data for them. So here's the geometry. Here's what I was saying before. So you can imagine a star basically is, you know, at infinity as far as we're concerned. You have an asteroid moving, you have the Earth moving, and that geometry causes, you know, what we call a shadow to go across the Earth. And most of this motion, by the way, is caused by the Earth's motion. The Earth generally moves faster than the asteroids we're looking at. So you end up with a path, and these paths, you know, generally I think go west to east, but some of them even go north to south or south to north. And you get a number of observers across the shadow path. And we know where the observers are. We know what time they took when the star disappeared, when it came back. And from that we can recreate the shape. So you have observer A up here in Edmonton, you know, and he didn't see the star blink out. So you just draw a line across here. And you have somebody here in Lancaster, you have somebody down in Norfolk, and somebody down in Savannah. They all saw it blink out. And then the person down in New Orleans or whatever didn't. And from that you know this asteroid's width was there, there, and there. And you can connect the dots and measure the size and roughly the shape of the asteroid. So by the way, my thing, why I talk to clubs about this is because we need more observers, right? So if I put 3 times as many observers across that, I get a much better image of that asteroid. So that's why we try to recruit people into this pyramid scan, I mean, whatever it is.
So the asteroid is tumbling more than likely, but it's
slow.
such a slow rate compared to...
So going across the U.S., typical asteroid is about 4 minutes to go across, and typical rotation periods are a couple hours. So yeah, it can move a little bit.
Yeah.
In fact, I'll show you one in a few minutes. We can think about whether the rotation did something to some of our data there. In fact, it's this one. Perfect. So the video I would have shown, if it worked, resulted in this. This is our Patientia, I think it's pronounced, something like that. Again, I butcher pronunciations. So this is the data we recorded on the 5th. So I was dead center on that one. So my chord is, I think, number 14. Yeah, 14 here and here. But you can see how nice and round this one is, or elliptical, really. But there was somebody who timed at the exact same time as, or the same line as I did, who was number 15 here. So here's my disappearance and his disappearance, his reappearance and my disappearance. So you can see there's a significant difference there. He was in Tucson, I was in Maryland. So could that have been a little rotation? I don't know. Or it could have just been an error on one of our parts. But that shows you how well you can map when you have over 20 chords, 20 lines across the asteroid. Yeah.
What kind of tolerances are you hoping to get in terms of size? Like how precise are these measurements in an ideal situation?
We time generally the input data to about 100th of a second. You know, we're recording at 30 frames a second, 60 fields a second. So we can do factor of 3 or 4 better than that.
I'm saying like meters or, you know.
It depends on the geometry.
Okay.
So that's the result of one of our good runs. And then you get these really odd shapes. So here's Hertha. Now Hertha looks like an orange slice. Like something happened to that guy. It got whacked somewhere along his lifetime.
Are professionals applying some mathematical statistical treatment for this data? Or they take it to another level of analysis?
Generally what's happening is there are people who do asteroid lake curves. A lot of amateurs do this as well. And they just look for the lake pattern. And there's software that you can take that pattern and get a shape of an asteroid with certain caveats. One is they don't measure the absolute size. So if it's a high albedo, a very bright asteroid, it's really smaller. If it's dark, it's really bigger. They can't do that.
So you get the relative proportional dimensions.
Right. Right. Where we give absolute size. Our size measurements are absolutely bulletproof. And the other thing
so many
is
measurements across a wide swatch of the Earth.
I'm sorry?
Because of the large number of measurements over a large swath.
No, any one chord is, you know, of order, maybe say a kilometer of resolution on the asteroid, or a couple of kilometers. And that's just purely from the geometry and the speed of the asteroid motion. But the other thing that the people doing light curves can't tell you is if there's a depression or something coming out. They can't resolve those two. So on this one, you know, it could have been something going outward as opposed to something going inward. And they can't resolve that either. So we're complementary. We fold those two types of data together to get a good model of the asteroid. So they take our inputs and add them to the light curve. Did I answer the question? Good enough? One other thing to point out on this one before I go on is if you look at the names of the observers here, you see that Scotty Gebhardt has about 15 of these chords. Wow. Remember I was talking about the 35mm binocular? So Scotty has about 20 stations, what we call stations. So he'll put a video camera on with one of these little binocular halves on a cheap camera tripod and will 3-point. So just put it on a cheap camera tripod and we'll say, I'm going to put it on this star that's ahead in right ascension by an hour and a half. So an hour and a half before the occultation, I'm going to lock it down, start my recorder, and I'm going to run a couple of kilometers down the road and do it again. And he'll just go down an interstate or a straight highway in Kansas or whatever. Where is this one? This is Oklahoma. He was in Oklahoma, just I'm sure going up and down a north-south street or highway and dropping one of these every few kilometers and starting it up. And then when he gets down to the bottom, the occultation happens, he gets back in his car and picks them all back up. So, you know, people getting 10 to up to 15 chords happens. You need a bright event because you can't do this with C14s, right? You're not going to put 15 C14s out along a highway. But they, you know, they'll cleverly paint these things all black and they'll hide them in the bushes and do stuff like that. And they, a few times, by the way, the police have gotten involved. Stations have been occasionally stolen. So what you normally do is you hide them, you make everything black, but you also put a note on them and say, you know, if found, here's my cell number, this is not something bad that's happening. So when you do these, the typical event you get is like Iris, where there's, in this case, there were 5 of us observing. So you get good data, you get a good size and all there. You can see it's a nice ellipse. But we don't know anything about this side. We don't know where the tip really is here. But you know, that's my truth in advertising is since we don't have enough people, that's what we usually end up with. Now, when you do get enough people, the example on the right is IOTA gets together once a year and has a conference. And at that conference, we usually time it so there's a really good asteroid occultation at the time. So this is the one in Antiope. It was done a few years ago out in California. And we had 60 or so stations for that thing. So you can see how well we resolved the two asteroids. This is a binary asteroid, one having a bite out of it, the other one up here. So we have the Keck image that was taken immediately before this because we wanted to know the phase. And the Keck image is just 2 blobs. You know, so yeah, it resolved them, but you couldn't really tell anything about the size, shape.
The image you're talking about, what was that? What was that taken? I don't recognize the name.
It was with, how big is Keck? Anybody know? So it's like, is it a 10-meter telescope? It's
I think
one of
it's
the biggest
10.
telescopes.
10 meter. 10.
Okay.
So one of the best telescopes in the world
Yeah.
could resolve it, but couldn't give you the shapes. And then every 5 years or so, Sky and Telescope publishes one of our results to try to get people interested. So back in September, they picked another one, and the last 2 I managed to get in, which is just purely amazing. And both times they misspelled my name. I love it. They corrected it. It was submitted correctly, and Sky and Telescope corrected my name wrong.
I've got a very complicated name.
Yeah. So here you can see, you know, you got an asteroid here that's cut off. So negative chords where you don't get a positive, if you're the limiting case, that's an important chord because we know nothing goes below there. Anyway, so that's my claim to fame that every once in a while I get Sky and Telescope this way.
So how frequently, I mean, I imagine this is older than that, but is there periodicity with this that you will then capture 3-5 years later the same asteroid being, or is it one shot?
It's one shot across a star.
Yeah, but, okay.
So the chance of the same asteroid going across the same star again are pretty small in our lifetimes.
Okay, but we know the identity of these asteroids, so they're mapped, they're cataloged, right?
Yep.
Okay, so their periodicity going around is tens of years and all that sort of thing?
It's less than that, but yeah. Okay. We know very well we know well enough the orbits, but not quite well enough. Long after that.
Okay.
Yeah.
I think I'm kind of understanding what he's saying. Could you choose another star that it's going to go over and map the same object multiple times?
Oh yeah. In fact, we've had cases where an asteroid will be going through a star cluster, and you know, there's a couple. It won't be one in Lancaster or 2 in Lancaster. It'll be one in Lancaster and another one in Georgia. You know, that type of thing. Unless you're just crazy lucky, but it doesn't happen that often. But yeah, there's been some that have done that. That we had like 3 or so positives on the same asteroid with different stars within a week or something.
And does that give a very good identity of the profile of the asteroid, or is it?
If you know the orbital or the rotational period, you get different profiles of the asteroid. So then, you do a lot better.
Where does that information go? I mean, is it accessible?
Yeah,
or is it in a black hole in astronomy?
Every quarter we publish all our results. It's in the Minor Planet Circular, which I think is published by Harvard, either Harvard or MIT. So every 3 months we publish I don't know if it's officially called a paper or not in there. I think it's a result page or something. And everybody who contributed a result, positive or negative, to any of these gets credit. So you're listed, there's a list of authors, yay long, and every time my name's there.
So we're seeing this kind of information is presented in that. I'm kind of visualizing where this stuff goes, that it then is retrievable, or
yeah, it's retrievable if you know how to access it and use it. Yeah.
Right, but I mean, is it then presented in the paper or in the pamphlet like that?
Some of them,
like that?
not all of them.
Okay.
But all of them are published online. So there's I think I put at the end of the links I have at the end, there's a results page that the North American coordinator keeps. And everyone that had any positives, even if it's a single positive chord across an asteroid, They're all listed in there. So I can go back to when I started in 2007, I can go back to my first positive and pop it up there.
So, I mean, that's kind of cool. You know, you get the pat on the back or whatever, but that's really not that relevant. I mean, it's what the science is, what we're learning that's important, and what is it saying, rather than this being an esoteric activity.
Well, okay, so there's two things. One is the size of the asteroid, right? So that tells you about the albedo of the asteroid, and there's also a spectra of the asteroid, and from that you can know some of the chemical composition and what's going on the surface of the asteroid. The other thing is the shape, how irregular the shape is.
Right.
And that is of interest. The, you know, clearly the spherical or the somewhat elliptical ones are, I think, for most people not as interesting as the ones that have the
Is
chunks.
that information in this material that I just asked you about, or is it published someplace else?
There are, the online version has this.
Right.
The Minor Planet circular version has it in a different form that most people probably can't, other than professionals, probably can't ingest for a regular. And then, what's the third way? Oh, and then the papers we write. So the papers we write in scientific journals, real refereed papers.
That deal with the chemistry and all the other, yeah.
Well, typically we don't deal with chemistry. We deal with,
No, you
here's
don't.
what the real size is.
Yeah, but the professionals.
Yeah.
Oh, okay.
So, you know, the professionals who do asteroid stuff, like Southwest Research, you know, they're the ones who are funding us now to travel sometimes, because they want the data on a particular asteroid.
Mm-hmm.
You know, we want this one because we think it might be larger than we think, or we think it may be irregular.
Mm-hmm.
And it's cheaper to send a whole bunch of us
Mm-hmm.
than a couple of them.
Mm-hmm.
What does the position of the lines represent?
So,
you've got Arizona at the top and Arizona at the bottom.
yeah, because there's a strip going across the whole U.S., right? It's the shadow, so to speak, is a strip of land going from, in our case, probably Ocean City, Maryland to San Diego or something like that. So where you are on that stripe going across, somebody in Arizona can be the same as somebody in Maryland or close to it. Right? It's where you are on that strip.
Right.
That strip can go diagonally.
But on the diagram, why wouldn't Tony George be below Steve Conrad?
Because he's on the north side of the asteroid. There's no chalkboard here.
No,
We're sorry.
So Wayne Thomas is on
Let
the
me go
south
back a
side of
second.
the asteroid, even though he's in Arizona?
Here. So,
Okay.
you know, the guy here, down here in Mobile, Alabama, would be at the bottom of the asteroid, right? The guy up in Lancaster is at the top positive, and the guy up in Edmonton, even though he's really more west of you than north of you, he's further north along the path.
Okay, we can go.
So if the path went north-south, like they occasionally do, you're still going to have people, you know, somebody in, get a north-south path like this, somebody in Orlando and somebody in Edmonton would be on the top and the bottom side of the asteroid in that case.
Okay, but in that other one, you had in Arizona at the north, several at the top, one in the middle, and one at the bottom.
Yeah, because Arizona is a big state. The strip of shadow is probably narrower than the width between Tucson and Phoenix.
Yeah, I just wanted to say, like, if somebody was in the state of Washington, let's say, he might get the exact same reading as in Lancaster.
Yeah.
Because he's on that same.
Right, which is what I had happen on the one I showed here with that guy in Tucson.
Yeah.
He and I were on the same path. He was 4 minutes before me or whatever it was. So maybe there was some rotation, which is why there's a little difference there. All right, any chance this one's going to work? Probably not. I don't understand why these all worked last night.
Do you have the files themselves? You have the files themselves, like on your computer?
Yeah, let's see if we can do that. That's a good idea. But you guys got to see one of these, right? Okay, so this is the one I was going to show. Let me set this up. This is an occultation of the asteroid Agamemnon. Agamemnon is a Jupiter Trojan, okay? So I think this is it's one of the Greeks, and the Greeks trail by 60 degrees, and is it the Trojans? The Trojans lead by 60 and the Greeks trail by 60 or something. But anyway, 60 degrees out of phase with Jupiter's orbit. Okay, this one's actually working. Okay, watch the star in the middle. It's like a 10th magnitude star.
Now, the fluctuations you're seeing now. Oops.
Okay, so it's gone now. In 5 seconds, it's going to come back. 2, 1, there. Okay, so that was a 10-second one. Now, don't blink around the turn of 2 seconds from now. Keep watching. Don't close your eyes. You see that?
Yeah. And what was that?
What do you think it was?
A second asteroid.
Second asteroid. Why would you have 2 asteroids together?
Binary
Gravity.
There you go.
Okay, so this is a really technical question, but you want help doing this, so I'm going to ask it.
Yeah.
Do you have to worry about clock speed on your computer or whatever you're doing?
Oh yeah, we're going to talk about that. Oh yeah, that gets real ugly. We can go down a rabbit hole real quick. So anyway, that was probably the coolest discovery I made in my personal life, because when I saw that, I saw it live on my computer, I saw it blink out, and I knew exactly what it was. And there's still a $5,000 prize for the first person who does that, finds a satellite of an asteroid, and has it confirmed by completely independent means. So nobody's had that done yet. So the professional astronomers I work with, every time I talk to them, it's like, got any Hubble time to look at Agamemnon? You know, I'll split $5,000 with you. But anyway, for those few hours until I talked to David Dunham, who I was working with at the time, you know, I was the only person in the world who knew that was a double asteroid. And for Trojan asteroids, that was only the second one that was known to have a satellite. So here's just a little more background. That was in 2012. We had 5 observers, 7 stations, mainly in Maryland, and 5 of those were successful. We got a great measurement of Agamemnon, size and shape. And luckily, the one that got the satellite, mine, was high signal to noise, that C14, as opposed to the small telescopes that David Dunham was laying on the side of the highway. Here's the plot of what the signal level looks like. So we have software that analyzes our video and counts how many digital counts the star is, because the asteroid's much fainter. You know, went along, went to 0 when it was occulted by Agamemnon itself, then went back up, and then 10 seconds later, we had like a 0.4 second dropout caused by the satellite. Yeah?
Are there any specific stars that are best suited to look at to see the asteroids?
No, it doesn't matter. The only thing you say is bright. Right?
Well, I just had an idea. It's so it will. But you know, interstates are already marked off in mile markers and tenth of a mile. If you were to put a camera on every, I don't know, mile or 2 miles or more the better, could you pointed them all at the same star and had them charged with a battery? You wouldn't have to go tend them to be up on a pole all the way down north-south or east. North-south would be better.
Yeah, you'd have to point them each time, because you know there's millions of potential stars that can get occulted, and any one star might get occulted once. Well, A, they have to be near the ecliptic for the most part, right? And B, they might get occulted, you know, once every 20 years. I don't know. I'm just pulling that number out.
That's why I asked if it was like one star if you pointed it.
No,
because you have an even line.
Imagine an array like that that were all go-to telescopes that can be remotely programmed. Yeah. You know, then it could be, you know, Tuesday night I'm going to point to this star in Aries. You know, Wednesday early morning I'm going to point to this one in Taurus. And if you could do that, You know, that's a great system. Now, on the West Coast, what they've done is they got an NSF grant to give high schools and other institutions like that C11s and good cameras, with the understanding that there would be somebody in charge of it and they would collect data like this. So there's like a picket fence of stations up and down from Washington State to through Nevada into Lower California, in rural areas where they deployed these telescopes. Sorry.
How long does it take for the shadow to go across the United States?
It's like 4 or 5 minutes, something like that.
So you could theoretically have like a picket, like a gate on all the states, and then get one of those pictures like you had with like 20 different lines, and then you could actually put them in a time sequence and see how much the asteroid tumbles.
Well, you could, but it, you know, over the course of 4 or 5 minutes, most of them go hardly at all.
Okay.
So you just wouldn't get much that way.
Oh, go ahead. Go ahead. Sorry. So basically, you have somebody who coordinates which star you're looking at. Is that how that works? Or?
No, well, we have all, by the way, all our software we use, I'm trying to get people on, is all freeware, and we have software that predicts. So this is cult software that uses a whole bunch of different star catalogs. And again, we could talk about star catalogs forever, including new stuff from Gaia satellite, the European astrometry satellite. So that software, it says, you put in that software, hey, I live in Lancaster, I'm willing to drive 50 miles, I can see to 12th magnitude, I don't do Thursday nights, whatever. Put it in there, hit the button, and say, what do I got the next month? What do I got the next year? And it will spew out a huge list of stuff, most of which is garbage, and it'll be like 0.1% chance. But, you know, 1 or 2% of those are going to be a very high percentage shots. Yes, sir?
Do you see any application to use this for, I know industry is interested now in the next 50 or so years to start looking at asteroids for mining purposes. And that's going to put all sorts of money into
the problem with that is they're interested in near-Earth asteroids. Okay. They're not going to go out to Main Belt and harvest those. Near-Earth asteroids, we have a real problem predicting when this happens. So eventually, maybe, but not in the near term. Okay, so here's here's our shadow map of Agamemnon. So we know how big it is and how elliptical it is, and then here's the little possible satellite there. So I think the satellite's probably about 4 kilometers across, could be as large as 10. And it's about 300 kilometers from Agamemnon. They have done adaptive optics on Agamemnon before, but the scientists we work with said that the adaptive optics they used would not have resolved this. So it's not surprising they wouldn't have found it. Like I said, only the second Jupiter Trojan known to have satellite, and we wrote a real referee paper on this. It was published in Planetary Science, I think, a couple of years ago. Another cool case, and these are rare, right? You have a cool one every couple of years, not to mislead you like you're going to have this happen all the time if you try this. But also in 2012, just a couple months later, there were 9 of us setting up 14 stations to look at Main Belt asteroid Nemesine, however you pronounce that. People from California to Maryland, 6 successful ones. Again, we got a really good measurement of the asteroid, and when we looked at the star, we found out the star was double. And we ended up publishing a paper on that in a year or so after that. And here's what you see when you have a double. So, here's your baseline star, goes across, then it occults the first star, goes across, and then it occulted both stars, and then coming back up, the first star appeared again, goes across, and then both stars were back. So you get a step function like that. Now, the cool thing about this was we were really scratching our heads when we first got it, because the data I took didn't have the step function. But what happened was, mine went across to here, down to here, went all the way across at that level, and then came back up. So I only had an occultation of one of the 2 of the double stars.
So your angular position on it captured just the single star.
Yeah, exactly. So you can see
the resolution is amazing.
Oh, yeah, you know, like I said, we're getting better than 100th of an arc second. We're closer to 1,000th of an arc second for real good data. And you get this with little telescopes.
Well, the baseline is just so huge. I mean, and, you know, considering the triangle.
It's just really cool, inexpensive science. And that's what the asteroid looked like. And of course, you get double the resolution of the asteroid because each chord now, not that it means much, turns into two little chords side by side. So here's mine where one of mine has a break and one of it doesn't.
I mean, the interesting, I mean, we're not looking at pixels per se in terms of kilometers of, you know, looking at something on the moon or on Mars or whatever. We're looking at the light itself in terms of its intensity, not trying to get to a geometry in the plane.
Exactly. Exactly. In the old days when we were doing this, they were using photometers, single pixel photometers. You don't need to resolve anything.
So
you just need to keep other stars.
That's why you don't need big telescopes if you're not really resolving anything.
You only need big telescopes to get to fainter stars.
Yeah.
So it's just how big your light bucket is. Now, the really other cool thing about Neon-Orionis when we did this is it's, and this is arguable, like I just ran into an expert on FU Ori type variable stars. There's a published paper saying the star we saw is one of these special variables. And the authors of that paper, who were a couple of Russian guys, had published a paper talking about are Neon-Orionis one of these type variables, and were these type variables variable because they're double stars? They didn't know. So we contacted the authors when we published it. We said, hey, you guys, we proved this is a double star. Does that help you at all? Now, the counter to that is, at a recent meeting, I met somebody who is a scientist who's interested in these type stars who works at Space Telescope. And he said, Neon-Orionis is not that type of variable. He said he didn't care what the Russians said. So anyway, but he still thought it was interesting it was done. And then you guys have seen this. This is the Charco, is that how you pronounce it? Where this is a amateur professional collaboration looking at this Centaur occultation that happened a couple of years ago. And they set up a bunch of stations in South America, I think. And they got this pattern where they got a little dip, a big dip, a whole occultation, and then that and that. That's how they discovered the ring system around that Centaur object. And like I said, amateurs were involved with making this discovery. This was professional data because it just looks better.
My co-processor's back still on the other
yes, sir.
Between the Americans and the Russians and all that split.
Yeah.
What did they learn from spectroscopic analysis of that star? I mean, the agreement was that it was a double star.
We proved it was a double star. It was not previously known to be a double star.
And so the Russians, did they do spectroscopic analysis? Mm-hmm. And it did not reveal?
Apparently not. Apparently they were not aware it was a double. I don't know if they didn't have the type of resolution.
Yeah. You would think with having the data you had that would likely show up spectroscopically.
Yeah, I don't know.
Yeah, I understand.
Unless it's too tight. You don't see a shift in the lines on the spectrum.
And you're also, with the spectroscopic technique, you have to watch it for time, long time period, to see if it's in fact binary. Otherwise it gets smeared together. You need time to watch the rotational effects in order to learn about spectroscopic.
Yeah, okay.
All right, we got to pace a little bit here. And then I'm sure other people, you've also seen Pluto results where you measure the atmosphere of Pluto. You notice there aren't sharp edges there. So that's a star going through Pluto's atmosphere, fading out, and then getting engulfed by the planet's disk. Again, amateurs do this all the time as well. So what do you need to do this? You need to get a prediction. You have prediction software. We have two different types of software. The one I was talking about where you make your own predictions. or you can use a web-based program that uses other people's predictions and sorts them for you. You say where you live, what you can look at, and it just gives you a list, and you pick out the list, and it'll even remind you to go out and observe. You need a bunch of observers across the shadow path. When you're a single observer, you get one chord across an asteroid. It's fun, but then you're a collector. You're not really getting any scientific data. You need multiple chords across an asteroid. Your location, you can get that from a map or your GPS. Here's what the web-based system looks like. This is actually for Lancaster. What's coming up from today down, and I'll give you a couple examples of these in a minute. So you need to time very well. So you need to have a computer that has a real-time operating system, which I don't think most of you have, etc. Or you need to use technology that's 50 years old called analog cameras. So we generally use analog video cameras. We use parking lot security cameras. They're cheap. They run from $120 up to a few $100s each. With an 8-inch aperture at f4, you can get to magnitude 11 or 12 in good conditions. You just time when it disappears or reappears. You put time in. I got a time inserter box over there. You remember the time that was on the bottom of the video that I showed you? That's time inserted. So each frame of the video, we stamp a time on it well before it gets to a computer, and then we record it elsewhere. So that way the timing is absolutely bulletproof. Hardware, I mean, most of you have some of this, but here's the things. I mean, you already have a telescope and all, I'm assuming. You need a focal reducer, you need a video camera like I told you. You need a time inserter, you need some sort of video display. Probably you have stuff in your attic that would work for that. A video recorder, bunch of options for that, and then old RCA cables, which you may have a closet full of those as well. And here's a whole list of video cameras. I'll give this presentation to you guys if you want to put it on your website, by the way, so don't worry about memorizing this. And then many people will do like I did on the left there is my score box. So it has a video monitor, it has a video splitter, it has a time inserter, and a battery all in one box. So I just plug the camera in, open the box, turn it on, run the battery, and I take my data that way. So my first experience, David Dunham gave me a bag of cables, electronics and all, and said, you're an engineer, you know how to do this. And needless to say, it did not work that well. Analysis for reporting, we have two freeware packages that will take your video, you import it into the telescope as into your computer as an AVI, and it will analyze it and tell you the signal level and measure the signal level versus time, and it'll even read the times on the bottom, amazingly enough. And then you report your results to our coordinator in North America. That's a gentleman up in Rochester, New York. And then, like I said, quarterly published in the Minor Planet Circular. So your graphs look like that. Your report form looks like this. It says where you are, who you are, what equipment you used, when it disappeared, when it reappeared. So for those of you, I think Lane's already tried it and went away from it. Here's just my little pitch to think about it again is a lot of people tried it and gave up because you don't get many successes. Single operator in one location, you might get 3 to 6 positives a year depending on the size of your telescope, but that requires you trying every week, like one a week. So there's a lot of unsuccessful setups, wasted time, and a lot of this is because we can't predict these things very well. But the Gaia satellite is going to give us unbelievably good data on where the stars are and where the asteroids are. So we're already starting to use that data for star locations. We started using it as of September. And that, the first time we did that, allowed us to find we had an error in our predictive software, where there was a round-off thing going on that was affecting some of our predictions and having them be grossly wrong. That's been fixed because of that. In a year or so, we're also going to have proper motion on the stars. And then a year or so after that, we're going to have asteroid orbital data. And by late this decade, we're expecting that we're going to be just on all observations. We're going to be within a few kilometers. But if we say it's going over your house, you can bet. So that's what's changing. Goods and bads. The positives are, I mean, here's a real easy, reasonably priced way amateurs can contribute to real science. It's a team sport. You announce when you're observing on the web, other people see it, and then there's the old peer pressure kicks in, you know. Oh, I gotta get up at 3 in the morning because I told Joe I was going to do this. And I get up. I was up at 4 in the morning this morning making an observation, supporting some of the other guys who had positives. I had a negative. And we have a ton of freeware that's available that just will amaze you how good it is. The negatives of the weather will just break your heart, because not only do you need clear skies, you need a clear sky at a certain time in a certain direction. And just think about that at a degree of difficulty. And then there is, you know, like I said, there's a few $100s worth of cost. There are other uses for these systems if you buy one. Some people will put a wide field lens on it, C-mount lens, and use it as an all-sky camera for meteor falls. Some people are doing lunar impacts, the dark area of the moon, during meteor showers, looking for lunar flashes where the meteor hits the moon. And believe it or not, a lot of people are using them for UFOs. So if you're a UFO person, I'm not. IOTA, so we're a group that supports all this. We publish our own journal several times a year. We have a Yahoo group. We have free software. We have books and pamphlets, including a 500-page book you can download that I have a link for in here. And you can have all the rights of membership except for the journal for free, or you can pay $25 a year, which is really every few years because they don't collect it very often. You can be a full member. And it isn't just asteroid events, it's lunar occultations, lunar grazes, etc. There's also an AL club program, you know, like your Messier program. Badge number 1 is still out there. I'm the administrator of this, so I'm waiting for somebody to get badge number 1 for this club. Next opportunities, there's a really good one in a week and a half up here. Good run. 14-second long, 60 seconds if you're in Lancaster. If you move over to New York, you can get over 90%. And good magnitude drop, everything about it's good. There's where its path is. So the green line's the center of the path, and the blue lines are the edges. So you can see Lancaster right on the edge, the right edge there. And then there's another one, Terracina, November 30th. A little bit fainter, like from here, 45% chance. If you go over at Pottstown, it's a 95% chance. Not quite as big a magnitude drop. Excuse me. There's the center line there. And then here's a bunch of resources. Like I said, I'll leave the presentation, so if you want to link any of these, you can. You're welcome to email me. I'm happy to help anybody get started. Questions?
Do you ever have trouble with like airplanes or birds or things?
One of the things we had to disprove on the satellite of the asteroid was one of the things was, could it have been a big bird going through my field of view? So we talked to ornithology people about what's the biggest bird that could be flying at 4 in the morning in January, and what's its aspect versus a C14 angle, and we showed that it wouldn't, the biggest bird you could imagine wouldn't have enough magnitude drop to produce that. So there's that. Planes, we also thought, what was the biggest airplane that could go through the field of view and how low could that have been? So yeah, you consider all that, but nothing impacted us. And nobody I've ever known has run into that before, where it's been, oh my God, it could be a bird.
I didn't know. I didn't get that.
But what usually happens is you usually have multiple stars in the field and they'll all blink out if you have a cloud or a bird or something like that. Yeah.
Is it ever possible for an asteroid to hit planet Earth in the near future?
Yeah. But we don't measure that. But that's near Earth, and near Earth asteroids we really can't measure the size of. We just don't have any way to do that with what we do.
Oh, you wouldn't be here if there was. Be someplace else.
Anything else? The second box on the right there, by the way, is a tester for testing our cameras, proving how fast, or excuse me, how well the GPS timestamps are. There are 500 LEDs on that. Each of the LEDs light up for 2 milliseconds in order. And you just put your camera at that and you record it. And then we have software that analyzes that and tells you how much time delay there is between the timestamp on your video and what we really know we're giving you. And again, the sort of thing my wife just loves me just to leave that around and running because it just looks cool. Anything else? I think we're running out of time here.
Yeah, I just want to add a couple of comments. Steve mentioned that I tried this years ago. It was in the 70s, probably the early 70s, and it was just barely getting going. I tried it for 3 years. Never managed to record. I had negatives, no positives, but I only wound up with 3 or 4 observations because of that first bullet under problem areas, weather. Okay, just a bad run of weather. But you can't imagine nowadays, I mean, our data reduction back then was unbelievably horrible. I mean, it was awful. There was no GPS. You had to do everything with maps, you know, in terms of coordinates, where you were. And sometimes you had to guess about where you were. There was no verification of any kind unless you wind up at a corner of 2 streets. And even that was always suspicious and so on. So it's, I would encourage anyone to give it another try. I might. It should be, I'm not going to say easier, but you can get much better results nowadays than I could ever get back then.
Okay, thank you. I have to drive home and then have to get up at 5:30 again tomorrow. But at least I don't have a 4 o'clock in the morning.
There you go. Other than that.
Dave, just wanted me to remind you, next month I'm giving a talk on it. If you want to get into binocular astronomy or just observing the telescopes and you want to get a starter scope, I'll give you all the ins and outs of what to look for, what junk to avoid, because there's some junk out there, and then the different nomenclature, that's, you know, focal ratio, field of view, magnification, all that, what size is recommended, and what you can see in light pollution, whether it's really lousy light pollution, there's a lot out there, you still can do astronomy with a lot of light pollution. So I'll give you all the degrees of which you can see. So that'll be on December 14th, our meeting.
Thanks, everybody. Thanks for coming. You're welcome.
When do you get those? What email said before Thanksgiving? Okay. You're partially pregnant.
Yeah.
You got one of those? Yes. When are you starting? Yeah. What are you doing?
Hello, Dave. How you doing?
Yeah. Some more cool.
Doing all of this.
You're going to be like Lane and go you don't make it. It wasn't easy. I'm tired, so I was like, oh shoot, I got to. Where do we know? And I'm an insomnia.
That has 2
during the night.
I really have been meaning to check
the
out.
There's eagle bones, dog bones. Those are easy to work.
I've been meaning to get like my hands on one. They're really stupid cheap, and
I'm not even sure I know where the heck it is at. Down near DAC, but
the electronics stuff. It's amazing what you can do with Arduino anymore. An Arduino beat an Air Force pilot at a dog plate on a simulator. Can you believe that? Like a little tiny computer with AI on it that can beat an Air pilot. You're pretty much power in a little package.
No, this is a DVR. So another way you can record your data is you can just plug what you're using and use it as a recorder. This one is what is used for radio controlled planes, for recording your in-cockpit experience. So it has a really nice monitor, nice
Oh, I made 11 years.
So this one, it's got this one. So you get the RF from the plane, you can actually record your line in the plane from the plane point of view. But it also just has a regular thermal input that we just record our data on. And I just use it as a backup to my computer. I've had some recording failures before, so I haven't felt.
Telescope observations, or, I mean, all you do, you live my life. You're not gonna have any more children. They're tied up for 7.
Right. Because you were the trainer. Yes, that's what I thought. New England train, okay, maybe you
It's more of an astronomy, but well, I use 2. I use a red dot, I use a tower. So I'll take red dot there, just because that gets you in there.